Hello friends. In this review, I will again touch on the topic of modernizing the APC 650 uninterrupted power supply, specifically replacing the standard lead-acid battery with a lithium iron phosphate one, which is more efficient and has a much longer lifespan. I said again, because I have already made reviews on this topic. For those who haven't seen them, I will leave links in the description. In that case, the modernization was two-stage. First, I integrated the UPS into Home Assistant by installing a Zigbee relay with energy monitoring, and then I installed lithium iron phosphate batteries, but in the form of 4 separate elements and a BMS controller. The UPS from this review is exactly the same. It is installed on a less critical segment of my infrastructure. I also talked about its organization in one of the videos. You will find the link in the description as well. In this case, I decided to use a ready-made assembly solution with a declared capacity of 12 amp hours. In the video, I will show the real capacity of the battery and check whether it can be used together with a regular uninterrupted power supply designed for lead-acid batteries. Before we start, please like this video so that more people interested in smart home topics can find it, and subscribe to my channel to not miss new reviews and lessons. Battery type, lithium iron phosphate. Number of discharge cycles, no less than 4,000. Built-in BMS controller, protection against short circuit, overcharge, and deep discharge. Nominal voltage, 12.8 volts. Nominal capacity, 12 amp hours, 153.6 watt hours. Charge voltage, 14.6 volts. Maximum charge/discharge current, 12 amps. Standard charge/discharge current, 6 amps. Discharge voltage, 11.2 volts. Case size, 151 by 98 by 100 millimeters. Protection class, IP65. This type of battery can be connected in parallel and in series up to 4 units for each type of connection. An important point about delivery to Ukraine, which not everyone knows. AliExpress rules prohibit the shipping of batteries, so sellers, not just this one but practically all, use a workaround. They send 2 parcels, one for tracking in the personal account, the other, the real one, with the battery, the track of which is written in personal messages. Therefore, the track in the personal account usually shows the arrival of a small package. Several times I received just a nut. This time, this connector arrived. Sometimes it arrives earlier than the battery, and buyers, who do not know about this peculiarity, start to panic, thinking they have been deceived. But this is normal practice. The battery is delivered through the Mist Express service. In my case, it arrived even before the small package, which was delivered to a regular post office. Therefore, after ordering the battery, check the personal messages from the seller and don't worry when you receive a package with something you did not order. The packaging is sturdy. The seller took care to ensure that nothing would get damaged during transportation. Included was an instruction manual in English with parameters and technical specifications, about which I have already told. As I said, this is a ready-to-install assembly that includes both the battery cells and the control board, BMS. There is no need for soldering or additional purchases. The actual dimensions, including the protrusions on the case and the contacts on top, correspond to the stated ones, 151 by 98 by 100 millimeters. But, as you can see in this photo, its width is clearly greater than those batteries used in simple household uninterruptible power supplies. Here's how they look in comparison. The thickness of the lead-acid battery that was installed in the UPS is 65 millimeters. The length and height match. The contacts for connecting to the uninterruptible power supply are also identical. The connectors fit, so there's no need for any modifications. The actual weight of the battery is 1,845 grams. I remind you its capacity is 12 amp hours. For comparison, the weight of the lead-acid battery I just showed, with a nominal capacity of 9 amp hours, is more by a whole kilogram. For charging, I used a laboratory power supply that supports CC and CV modes. I set the charging current to approximately match what will be used in my uninterruptible power supply, 2.4 amps, but I remind you, for constant charging, currents up to 6 amps can be used. I'm powering the battery now. The unit is currently operating in constant current mode. The voltage on the battery is 13.76 volts. That's the level it arrived at. As charging progresses, the voltage rises. I remind you that for full charge, you need to set 14.6 volts. However, in uninterruptible power supplies, batteries are not charged to 100%. A buffer mode is used there. After the voltage reached its maximum, the BMS disconnected the battery cells from charging. The current dropped to zero. Overcharge protection works. I will be testing the capacity using a special electronic load. For those interested, I will leave a link to it in the description under the video. I will discharge it with a current that is stated as the maximum for continuous load, 6 amps. The voltage on a fully charged battery is just over 14 volts. The capacity counters are still empty. I turn on the load. In the bottom line, you can see that the timer shows 12 seconds. This is just the beginning. The voltage dropped by 1 volt. The current power now is more than 78.5 watts. A 6 amp current will be maintained constantly throughout the discharge. 6 minutes after the start of the test, the battery voltage is 12.7 volts. The more the battery discharges, the lower it will be. In real use, a constant power mode works, where a voltage drop is compensated by increasing the current. Half an hour into the test, the battery has already delivered 40 watt-hours of energy. Considering its voltage, this is just over 3 amp hours, which is a quarter of the declared capacity. 1 hour after the start of the test, almost 84 watt-hours of energy, or 6.6 amp hours, have been delivered, more than half of the declared capacity. Another half hour later, the voltage dropped to 12.3 volts, delivered 120 watt-hours of energy, which corresponds to 9.5 amp hours. The test is nearing completion. 1 hour and 53 minutes have passed. Almost 143 watt-hours of energy, or 11.38 amp hours, have been delivered. The voltage dropped to 11.26 volts. According to the instructions, at this point, I was expecting a disconnection from the power through the BMS board. However, the disconnection did not occur, and after 3 minutes when the voltage dropped below 10 volts, I disconnected the load myself. During this time, 145.7 watt-hours of energy were delivered, which is almost 95% of the declared, or 11.659 amp hours. This is more than 97% of the declared. The result is excellent, especially since the discharge was at the maximum current of 6 amps. In my case, in real use, the current will be at a level of 3.5 amps, which will give an even better result. Now regarding deep discharge. In this photo, you can see that the battery voltage rose to 11 volts after the load was disconnected. As one could understand from the instructions, the BMS should have disconnected the battery cells at a voltage of 11.2 volts. But this did not happen. Is this good or bad? After some thought, I came to the conclusion that in the case of use with an uninterruptible power supply, this is rather good. Because the UPS itself disconnects the battery at low voltage, according to my information, somewhere around 10.7 volts. But if the BMS had disconnected the battery at 11.2 volts, it would have been an abnormal situation for the UPS, similar to if its battery was suddenly removed during operation. Now it's time to see how the uninterruptible power supply will react to this assembly. As I said earlier, I am testing the simplest APC 650 UPS, designed for 1 lead-acid battery. As you can see, I removed the standard battery, and to the wires that went to it, I made an additional external output. This modification was implemented several months ago. The uninterruptible power supply was used at that time with 2 lead-acid batteries, one inside, the other outside. Now I plan to use it with a lithium iron phosphate battery, but due to its size, it doesn't fit inside, so it will be placed outside. I connect it to the external wires, but the uninterruptible power supply is still turned off. The voltage has risen a little more, almost to 11.3 volts. Now I'm turning on the uninterruptible power supply. It started up perfectly normal. The battery began to charge, which is evident from the gradually increasing voltage. In this photo, you can see the charging current, about 2.3 amps, approximately the same as I used on the power supply. As the battery charged, the voltage increased, and after a few hours, I decided to check how the uninterruptible power supply would perform its direct functions with this battery. In this photo is a cold start of the uninterruptible power supply, meaning turning it on without external power, running off the battery like a charging station. The load is a 75-watt incandescent bulb, so the current, considering the inverter's consumption, is even higher than 6 amps. Everything is fine. It works as expected. The standard mode, switching to battery power when external power is disconnected, also works normally. This measurement was taken about 18 hours after the battery charging started. By calculations, it should have been fully charged long ago. The voltage is stable at 13.5 volts. Again, I remind you, in uninterruptible power supplies, batteries are in a buffer mode. They are not charged to 100%. For LiFePo4, 3.4 volts per cell is recommended, which is 13.6 volts, and in this case, it's 3.375 volts per cell. It could be a bit higher, but overall, it's within the norm. Regarding disassembly, initially, I did not rule it out, as I was curious to see what was inside. But the case is very tightly assembled. The protection class, I remind you, is IP65. After carefully checking everything, I concluded that disassembly would definitely lead to destructive consequences for the battery case, which would likely be impossible to restore at home. This is unacceptable for me, especially since the measurements and tests conducted are much more indicative. For its price, especially considering the sale, and it cost me $37, I consider it an excellent option with an honest capacity. However, it's important to understand that when used in uninterruptible power supplies, the capacity will be less due to the buffer mode of operation, but on the other hand, there will be more charge-discharge cycles. When used with uninterruptible power supplies, where you can adjust the battery operation parameters, for example, with a universal DC UPS, a link to its review you will find in the description, you can set a higher voltage. 13.6 or even 13.7 volts, which is acceptable for such a battery and gives a slight advantage in capacity. That's all. I hope this video was useful and interesting to you. I will be grateful for your likes. They will help promote it on YouTube. If you don't want to miss new reviews and lessons, subscribe to my channel. In the video description, you will find all necessary links to the store where this battery was purchased, to other reviews on this topic, as well as my Telegram channel, Facebook page, and a group for discussing smart home issues. Join us. It will be interesting. Thank you for your attention. Until we meet again, peace to everyone.